Hey there. In this video, I'm going to show you how you can use advanced data science techniques like causal inference techniques in order to understand an impact of a certain event, a major external event on your business, on the brand that you are managing or your own brand. So the example that I'm going to take here is that of the impact of the recent war, the recent escalation, the warlike situation that has taken place between Iran and Israel, and some of the other neighboring countries in the Middle East. So I have a few brands that I work with that I've been consulting, which have been impacted by this war because they are in the Middle East. Basically, most of them are operating out of UAE. So just wanted to see, if we can find a method which will be both scientifically correct as well as fairly easily interpretable to understand the impact of war on the overall sales, on the overall business of these brands. So this is basically, as you can see in this screen here, this is a fashion business, and it is based out of UAE, and we're going to compare four different causal methods. So causal inference basically is a tradition in econometrics, which tries to answer the question, what if. So basically it tries to establish causality through the question of what if. What if means basically a counterfactual, meaning that if this war would not have taken place, then can we actually understand what would have happened anyway, so business as usual. So that difference between that actual what happened because the war took place, and what would have happened, which we actually can never know, but these methods help us understand, that is basically called counterfactual estimation. So the difference between those two basically give us the impact of that specific event, in this case the war. So if you just go to this slides here, the first method. So this is the basic question again. So did the war starting on the February 28th cause a drop in fashion business orders from the UAE? So you can see the pre-period data. So initial data that I started with was basically from February 5th to February 27th, which is a period of 23 days. Ideally though, as we'll see in later slides, this has to be a much bigger time period for these models, this econometric causal inference models. And the post period is only again a very short period of 8 days, because that was all the data. As you can see, I'm making this video on the 9th. So yeah, February 28 to March 7 is the post period. But again, this should be ideally longer, so that you can actually understand the impact for a much longer period. And then you have the total number of orders, the total number of new customers and returning customers. So the whole idea is to understand the impact of the war on both new and returning customers. Now let's look at some of the methods. So the easiest method possibly among these is going to be interrupted time series, and this is based on a very simple concept of the change of slope. So if this was and the green line represents your the pre-trend, like where were the orders, rather where the orders already rising or where it flat. So you already you basically get a slope of this line, right? And then you also have so these are the basically the coefficients, this beta 1, beta 2 and beta 3, and you try to understand if there was a shift in the levels. This dotted line represents that period in time. um, you're comparing either side of that. So this war basically is represented by this dotted line. So the advantage of this, it works with your own data, and you only have to look at these three. And this final beta 3 here, this coefficient, this represents that slope change. So basically that's an interaction term that gives you, did the decline accelerate over time. That's the question that it tries to answer. So you have the level shift and the pre-trend effect. So these two are the other two coefficients. And after that, you can basically get the answer whether or not the war had an impact. So again, very simple method. I'm not going to the maths of it, or the technicalities of it, but let's mention a couple of shortcomings, like no control group, as you can see. So it basically does a pre-post analysis on the same data set. And then of course in the current data set, like I just mentioned, it had only a few post days, which is not ideal. Let's move on to the next one. This is actually a complete package. This is a Bayesian structural time series package offered by Google itself, and this is called Causal Impact. Has been around for a while. I've used it for several projects, and while ITSA is the go-to if you are just trying a simpler approach to start with and a manual approach. But Bayesian causal impact is also pretty good, and the advantage of this is that this is going to learn the seasonal or the time series aspects from your data. Is going to do that time series analysis on its own. So you don't actually have to provide that specifically. You can provide covariates, which should not be impacted by the intervention. The covariates can be again other external factors, just to rule out any other thing that might be impacting the changes that we might see after the war started. So again, like this is of course important, because if you're trying to understand the counterfactual, meaning how the data would have actually looked had this incident, this event, this special occurrence not occurred, this war, in order to understand that, you would have to obviously eliminate all other possibilities as well. So it learns from your order pattern before the war, forecast what should have happened, the gap, basically this gap here represented by these vertical red lines, that represents the causal impact of war, and it gives the probability that and because this is a Bayesian system, it's a very simple interpretation of the probability, the statistical significance, the 95% chance that the war caused a drop. Example output. So from this dummy example, you can see that there is a high possibility that it did cause a drop. So 30 orders per day, that sort of estimation, that is the kind of output you will get. This is actually ideal for this sort of scenario. One event, one market. This is basically what you would ideally choose for that. So you can see that no control group here is required. And but the idea is that, again, like if the war is taking place everywhere, then it's kind of, and it's not taking place in some cases. If it's taking place everywhere, then it's another matter. But if it's taking place in some cases, in and not in some other cases, then it's tricky to use this one. But you can understand, like if it's UAE you're mostly concerned about, and it's it's impacting most of UAE, then it's probably a good reasonable method to go for. Then you have difference in differences, and this basically compares UAE orders versus similar market not hit by the war. So you are also comparing this time with other markets this time. So you are bringing in the concept of controls, and this is a very very strong industry standard in this sort of causal inference measurement problems, where the logic behind it is that if both the markets move together before the war, any divergence after is basically equal to the war's effect. So you can see that there is this concept of parallel trend. That's very very fundamental to difference in difference. These two, the blue line and the gray line, they're basically moving very similarly. Of course they have the slope is parallel, and this is again, this may not be exact, this may not be in an this is ideal in a real world scenario, this might be slightly different, but if they're very similar also, there are some checks and balances in place. You can actually consider that as a control market. So you take that, basically the whatever direction it moves. So you can see the gray line is taken as the control, and it's used to measure the counterfactual. So basically, since these two were moving very similarly in the pre-trend period, in the pre-event period, so it's expected that the blue one also would have moved in the same direction, but it did like this, the one that dipped below. So the difference between the two gives you the causal impact. So again, gold standard for policy or impact analysis. This is impact analysis, and it controls for external factors automatically, right? Because you're taking parallel trends, right? So you're taking, the concept of difference in difference basically eliminates other factors. So there's the other thing is, of course, like so far what we've been talking about is data from one market specifically. So suppose for entire UAE, or you might be actually looking at any specific geography as well. But in this case, you actually need to compare it with another market. And then parallel trends assumption must hold, like I just mentioned, like these two should be moving in the same way. Let's move on to the synthetic control method. This is very similar to DID. The only difference is that instead of one market, you actually take a blended combination of several other markets together. They give you a very nice counterfactual. So you can see that there's a blend of multiple markets here. Just an example of several other countries like Saudi Arabia, Oman, Kuwait, and Bahrain. So together these basically give rise to a fake UAE with which you can compare. So a very fake market, by fake I mean a synthetic market, which is basically a blended output of a blended market, which is a combination of several markets. So again, very similar to DID. The concept is very similar, which is why the graphs also look very similar, but just the mathematics behind these methods, they vary. But as you can see, in this case, you need to actually have multiple markets for comparison. If it's available and if the math works out, it's tricky to get the math to work. That is one of the demerits of this, and it's pretty complex to implement because of that. But it has a very credible counterfactual, more credible than ITSA, as you can understand, because you're taking in multiple markets to actually sort of benchmark against, and you also have to remember that it works when no single market is a good match. So if unlike DID, where it's based on one market as a control or as a comparison for getting the counterfactual, if you don't have any such one market, then the synthetic control is actually a better alternative. So yeah, so to summarize, like which method fits the best. This is a nice little summary. You can see in terms of complexity, ITSA is very low. DID and causal impact are somewhat in between. To be honest, though, causal impact I'll say is very low as well. Like it's very much plug and play. And then you have synthetic controls where the complexity is pretty high. The confidence level is very high in synthetic control. It's moderate for ITSA, understandably. And but again, this is the best place to get started with it, I would say. And yeah, so quick directional check, best single market option for causal impact when you are selling in multiple markets, and yeah, 2+ markets, and you actually have a good single market to compare against. And synthetic control, it has maximum rigor, but it's also mathematically very robust, so therefore it's also more complex. So yeah, what's the recommendation then? Then you probably should start with causal impact. Like ITSA looks the simplest, but causal impact is doing a lot in the background, and as long as it is not causing an impact, you can choose some covariates like any other external factors like inflation or something else, anything else that might not be affected by the intervention. So that's the tricky part. You have to choose the right kind of covariates, because inflation can also be actually, it in fact is very commonly affected by things like war. So you need to choose those external covariates like competitor pricing and anything which in the short period might not actually be affected by war, right? They may be. So you just have to like think properly what covariates to choose. uh, Otherwise it's only going to look at historical data, and that often gives a flat counterfactual. Just as a it's like a pro tip. If you don't give any covariates to the cause and impact model, it will give you a flat counterfactual, which means that it's not going to understand any possible variation in the future. So the proposed approach therefore start there, hopefully with some good covariates and with a proper date range, which is not just 20 days, and then validate with ITS as a sanity check on the direction, if directionally you're right. And then if you do have multi-market data, then consider DID or maybe even synthetic controls. So this can be your sort of workflow to sort of properly gauge the causal impact of that specific event. So this was just to give you an example. This is the case of the war in Iran, but you can easily extend it to any other such specific events or interventions like holiday effects or any other kinds of events or occasions, like even Black Friday. That sort of a thing you can estimate like this. Yeah, a lot of these methods you can see are also very non-intrusive, right? They don't actually cause any kind of major interruptions in the work that your marketing team is doing, and that's a very important thing. But again, you should not be changing too many other things in order for these to work as well, in order for this estimation using these methods to be very accurate. So hope this was useful. I did not want to make this video too technical. I made other technical videos. You can go check them out in my channel. Or if you have any specific requirements or you want assistance with this, I do help agencies and brands with this sort of stuff. So do reach out to me, do mention in the comments or reach out to me via LinkedIn. More than happy to discuss. So thanks for watching and I'll see you in the next one.